All right, so let's get right into section 4, unit 4, section 3. And it's telling us that we have BWN, BWN prime, and BWN prime prime. And it says describe the feature of BWN that indicates rigid motion was applied to it to result in BWN prime. Okay, there's a couple ways that we go about it. I have a real quick and ugly version of BWN. If I put a point on the origin and I rotate it, you can see that it easily matches that. That's a pretty good indication that it was a counterclockwise rotation of BWN. You could also do some point analysis here, and you could say that point B, call this green one. Make this one green. Make this one green, and we'll make this one burgundy. Right, and we'll say that we'll say point B here. Point B was -2, 3. That's point B, and then point B prime. Point B prime was -3, -3, -2, and you would see that the relationship of those would then become, so the x's and the y's, the x's and the y's flopped, the x's and the y's flopped, and the 2's stayed the same, so the x's remain the same, but the y's turned negative. So the algebraic description would be x comma y, and that is, I didn't show any of that on the thing, and that is conducive of a 90-degree counterclockwise rotation. 90-degree counterclockwise, 90-degree counterclockwise rotation. Right, so that's how I pulled these points off of the green triangle, these points off of the red triangle, and that became a 90-degree counterclockwise rotation. Okay, show the feature described by mapping information on B and W. Okay, so I'm going to map one of the vertexes from B and W. Okay, so I'll go ahead and map B onto B prime. All right, so that's a 90-degree mapping of a counterclockwise rotation. I'll show a little 90-degree mark. So that's a C green mapping line. Okay, so I'm going to go ahead and next one is complete the table. So B to BWN to BWN prime. So that is the green to, I kind of already did that. Right, so this was a counterclockwise 90-degree rotation. And the algebraic description is just what I said up here already, and it's going to be x comma y yields -y comma x, and you can see that those kind of derive from these two right here. Okay, then we have a translation from BWY prime, or BWN prime to BWN double prime. That's what it's asking for right here, BWN prime to BWN double prime. So it's going from, we'll call that triangle burgundy to triangle blue, right? And since I have both of them on the coordinate plane, I'm going to just go ahead and do the coordinate plane counting. All right, so I'm going to go my x-axis first. I'm going to go 1, 2, 3, 4, 5, 6, 7. That's a delta x. Delta x equals 7. And then down is 1, 2. So my down for n would be delta y equals 2. right? So that is going to go down, so it's negative 2. Okay, so this is a translation. This is a translation. It's a translation because it did not change orientation. It didn't flip, it didn't rotate, it didn't spin or nothing. Right? And remember, the algebraic description is going to be x comma y, like every algebraic description ever. Right? So it's going to be x plus, and this was a plus because my x went from negative 7 to 0. It got added. So it went plus 7 comma y is going to be minus, it went down from negative 4 to negative 6, minus 2. That's going to be applicable to any point on this anywhere. All right, so moving on to the next set. All right, so the next set is going to be, okay, well, what happened between here and between, got these two triangles. I got triangle RKH and I got triangle BYT. The R is on the top here and the B is on the bottom here. So that's kind of a giveaway that something weird's going on. Okay, so that kind of helps out. That's a key indicator there. Okay, and it says RKH is the pre-image, and so my RKH is the pre-image. Okay, so go RKH is the pre-image. I'll go green is BYT is the after image. Okay, so B is right here, and R is right here. R is right here. So R is right there, and B is right here. Okay, so you can kind of see that better. This is Y, this is K, and this is T, and this is H. All right, so you can see those a little bit better. So it describe the feature that indicates that a rigid motion was applied. Okay, well, there's a couple things here that you could do. The first one is you could say that the orientation changed location. The orientation and location changed. So that means that a rigid, and while that was going on, the all of the lengths of all the sides remain the same. So the orientation and location changed. Right, you can see that it both moved in location and the orientation changed, and it was a rigid motion, and all lengths remained the same. Okay, so it's asking us to draw our RKH prime, the result of the first transformation now was applied. So what happened first? Well, let's see the different possible transformations that could have happened. Right, so I have R, H, K, knowing that H and B, R and B are supposed to line up. So R and B are supposed to line up. Okay, so if that was the case, then I know in order for R and B to line up, a rotation wouldn't do the trick. Right? That wouldn't work. A rotation across the axis wouldn't do the trick. Or a flexion across the axis wouldn't do the trick. 180 degree rotation wouldn't work, right? Because it it doesn't give me the same orientation. But what if I reflected it across the y-axis? That would then give me my R. That would give me my R in the same spot, and then a subsequent translation would give me what I need to do. All right. So this is a reflection. So this is a reflection. Reflection across the x-axis. X-axis. So my gonna be x comma y yields x comma y, because things don't change, and then which one of these changes for a reflection across the x-axis? Well, the y changes, right? Because it goes from up here to down there. The x stays the same across reflection across the x-axis. Okay. All right, so moving on. So let's take a look at how that will look. All right, so let's go ahead and plot our R value. Go an R, and then a K, and then an H. And then, so our R value is going to be -3, 7. Our K value, let me maybe zoom in a little bit. There we go. Our K value is -4, 3. Our H value is -1, 1. All right, and we'll use red for our R prime, K prime, H prime, and our relationship is x comma -y. X comma -y is going to be our new x comma y. So our x is stay the same, -3, -4, -3, -4, and then -1. And then our y's change into negative y's, -7, -3, and -1. So in here we have our new points. So let's go ahead and plot R prime. So -3 and then -7. This is R prime. We have -4, -3, -4, and -3 is right here. It says K prime, wait, -4. What did I count? This is I counted wrong. This is -4. This is -4. That means this is -4. This is -4, which makes this -4. Sorry about that. R prime. This is -4, -3. So this is K prime. And then we have H, which is -1 and -1. Right, so we can go from here, and we'll make some. This is H prime. H prime. So we'll just go ahead and make our lines using a stack of index cards. And there's our. Oh, you guys couldn't even see that. So that is our prime triangle. Okay, so we've C. We're going to go ahead and say C red C red mapping. Okay, so then we're going to map the transformation from our prime to be from here to here, from red to green. Right, so it's pretty easy. It's going to be R to B. So R, just one vertex, I think it says. Yeah, one vertex. We're just going to do R to B. So C green, and I'll just go ahead and put the algebraic transformation. So R is 1, 2, 3, 4, 5. Delta x equals 5, and then y is 1, 2, 3. Delta y equals 3. So is x plus y, or x plus 3, our delta x was 3, comma, no, our delta x was 5. Our delta x was 5, and then our delta y was plus 3. All right, so let's go ahead and write our transformations here. So maybe back out a little. No, it won't let me back out anymore. Okay, so our transformation, our first transformation was a reflection across x axis, right? And that was from blue to red, reflection across the x axis, right? And then that was x comma y yields x comma negative y. The x stayed the same. When I reflect across the x-axis, the x stays the same, but the y changes. I reflect across the x-axis, the x stays the same. The x value stays the same, but the y changes. Okay. The next one was a translation and the value that it changes was x changed by 5, y changed by 3. Both of them were positive. So it was x comma y yielded x plus 5, y plus 3. And then the final question is explain how you know the sequence of preserved distance. Well, we know it preserved distance because the lengths of all figure segments remained the same, right? All these lengths here, they're all the same here, right? That's actually wrong. That's actually supposed to be, let's see, this one was 3, 1, 2, 3, this one was 3, this one was 2, that one was 1, that one was 1, and that one was 2. Yeah, so these are all congruent lengths there. So that's how I know they are all the same. Okay. So hopefully that makes sense for all those questions. If you have any questions, please reach out and let me know. Thank you.